You ever do that thing where you just look up at the night sky, see all those stars, and think, how did any of this even happen? How did we get here? Well, today we're going on a wild ride. We're talking 13.7 billion years of cosmic history, all to tell the incredible story of our planet, from a tiny, tiny dot to the amazing living world we call home.
I mean, it's pretty much the question, isn't it? It's what's driven us for centuries. So let's just dive in. Let's go find some answers, starting at the very, very, very beginning. And when I say the beginning, I mean it. It's almost impossible to wrap your head around this, but everything you see, everything you are, the Earth, the Sun, every single galaxy, it all started in one place, a single point. So small it's basically nothing, but packed with infinite temperature and density. The whole universe in a dot.
So yeah, let's start with Chapter 1, the origin of the universe itself. How in the world did we get from that tiny dot to the absolutely enormous cosmos we see today?
13.7 billion years ago. Just let that number sink in for a second. According to everything we know, all our best science, that's when our universe just roared into existence.
What's really cool is how our ideas about this have changed over time. The first big idea was the nebular hypothesis. Thinkers like Immanuel Kant basically said, hey, maybe the planet's just formed from a big cloud of stuff spinning around our sun, which makes sense. But then scientists started thinking bigger. They kind of zoomed out and stopped asking just about our little solar system and started asking about, well, everything. And that's what led us to the Big Bang Theory.
So, okay, how did it actually work? The Big Bang Theory breaks it down pretty simply. Step 1, you've got the singularity. That's our tiny ball. Then step 2, a massive, violent expansion. Just boom! In a blink of an eye, energy gets converted into matter. And here's the craziest part. Within the first 3 minutes, just 3 minutes, the very first atoms, the building blocks of literally everything, started to form.
And get this, that expansion has never stopped. It's still happening right now. Back in 1920, the astronomer Edwin Hubble proved that galaxies are all moving away from each other. The classic way to think about it is to imagine drawing a bunch of dots on a balloon. As you blow it up, all the dots get further apart, right? That's our universe. And we can actually still see the echo of that first explosion. It's this faint energy all around us called the cosmic microwave background. It's some of the best proof we've got for this whole story.
Okay, so the universe is born and it's expanding. Awesome. But it was still pretty empty. So how did all that space get filled up with stars and planets? Well, that brings us to our next chapter, the cosmic construction phase.
Everything starts in a nebula. These things are just these gigantic, beautiful clouds of gas, mostly hydrogen, and dust floating in space. You can think of them as stellar nurseries. They're literally where stars are born. Gravity just starts pulling all that stuff together, little by little.
So this whole process happens in stages. As a brand new star lights up in the middle of that nebula, all the leftover gas and dust start spinning around it in a big, flat disk. Inside that disk, tiny particles start clumping together, making these little round objects called planetesimals. And then, well, it's just a cosmic demolition derby. These planetesimals start crashing into each other, sticking together and growing bigger and bigger, until eventually you've got planets.
And that right there is how we got our home. Our own planet Earth was born from that exact same process about 4.6 billion years ago. But trust me, the early Earth was a place you would not want to visit. You wouldn't even recognize it. Yeah, not exactly a paradise, right? Forget about blue oceans and green land. The early Earth was a nasty, hostile place. Its first atmosphere was just this thin wisp of hydrogen and helium that got blasted away by solar winds almost immediately. So, how did we get from that to the planet we live on today?
Well, it all comes down to this one really crucial process, differentiation. Because the early Earth was basically a giant ball of molten rock, all the materials inside started to, well, sort themselves out. All the heavy stuff, like iron, sank down to the center, and the lighter, rocky stuff floated up to the top. It's just like when you see oil separate from water, but on a massive planetary scale. And this is so important because that churning liquid iron core created gives us our magnetic field, the very thing that protects our atmosphere from getting blasted away by those solar winds today. And what you end up with is the Earth we know and love, a planet with distinct layers. You've got that dense iron core in the middle, a huge rocky mantle around that, and then the thin crust we all live on right at the top. All right, so let's recap. We've got a solid planet with layers. Awesome.
But there are still two absolutely essential things missing if you want life: a decent atmosphere and, water.
This is where things get really cool. The planet started to make its own atmosphere. The process is called degassing, and it's exactly what it sounds like. Earth's super-hot interior, through millions and millions of volcanic eruptions, just started belching out enormous amounts of gases. We're talking water vapor, carbon dioxide, nitrogen, you name it. Our second atmosphere was built from the inside out.
Now, this transformation took a long time. We're talking billions of years. So after that first atmosphere got zapped away, degassing built a whole new one. Then, as the planet finally started to cool down, all that water vapor in the air condensed and started to rain. And when I say rain, I mean it rained for centuries, creating the first oceans about 4 billion years ago. But there was still one missing piece: oxygen. And that wouldn't show up for another 2 billion years.
So, we've got a rocky planet, we've got oceans, we've got an atmosphere. Sure, you couldn't breathe it yet, but it's there. The stage is officially set for the most incredible plot twist in our planet's entire story.
And right around here, about 3.8 billion years ago, is our best guess for when it happened. Deep in the oceans of a young Earth, life began.
So how does that even work? How do you go from rocks and water to life? Well, the modern scientific view isn't that it was some single magical moment. It was a chemical process. Basically, the right molecules came together in the right way to be able to make copies of themselves. And with that, you get the first flicker of life, turning non-living stuff into something that lives.
And once life got a foothold, it didn't just sit there. It started to completely change the entire planet. For over 1 billion years, it was all just tiny microscopic stuff in the oceans. But then, some of it figured out a new trick: photosynthesis. And this was a total game changer because its waste product was oxygen. First, that oxygen filled up the oceans. Then about 2 billion years ago, it started pouring into the atmosphere, changing our world forever and making it possible for all the bigger, more complex life, like us, to eventually show up.
And that's our story. From a single tiny point to a living, breathing world. A world that was first shaped by these huge cosmic forces and then completely transformed by life itself. It really makes you wonder, doesn't it? As our planet keeps changing, what's the next chapter going to be in this incredible cosmic story we're all a part of?